All right, so to finish up the graphing the polynomial function lesson, okay, we're going to put everything that we talked about together. So we're going to put together how to, our end behavior, what it looks like, finding our zeros, our multiplicity, and we're actually going to graph these functions, okay? We're actually going to graph it now. We've now covered how to find it algebraically. Now we're actually going to apply it. And this right here is kind of like a little, I don't know, kind of like all the nodes kind of summed into like one nice little area, okay? So we have to find and plot the zeros. And remember, in order to find the zeros, what do we usually do? We usually factor and then apply zero product property, okay? So we figure out what the zeros are, okay? After we do that, we need to figure out the multiplicity, okay? If it has an even multiplicity, it's going to what? It's going to touch, and here it says bounce off the x-axis, so it's going to touch and go, like stay in the same direction, like ricochet off. If it's odd, it's actually going to cross the x-axis. So we find the zeros, we determine the multiplicity, so we can have a general idea if it's going to cross or touch. Then we look at our end behavior, okay? That's what we do, like the whole arms thing. Is it odd? Is it even? Is the coefficient positive? Is it negative? Because then now at least tell us what's happening at the ends, okay? And then we kind of like, starting from our end behavior, we basically draw the graph backwards, bouncing off the zeros or going through our zeros based off of the multiplicity, okay? It's all summed up right here in this nice little tick page for you. Now we're actually going to apply it, okay? We're going to do an example. We're going to graph a polynomial function, all right? So what I need you to do is go to your notes, where the last example on your notes, okay, that says now let's put it all together. So we're putting it all together now. We're doing the last example that's on the notes. It says for this function, we have to describe the end behavior, determine the zeros, and state the multiplicity. Find a few additional points. I mean, in part C, you really don't have to do. It's more of like to kind of confirm that you're like drawing it in the right direction. You know, that's usually what C is there for. And then we're actually going to graph the function. So we're going to find all of this, and then we're going to apply it to our graph. Now, if you notice, this function is not like the other functions we did before. It's already what? It's already factored. So really, we could go straight to zero product property to actually figure out what our zeros are. Okay? But let's back up. I'm skipping ahead. But it is in factor form. We have to describe the end behavior. Now, to describe the end behavior, we need two things. What do we need? Coefficient and the degree. Now, when it's in its factor form, you have to look at basically the multiplicities. You got to look at all the degrees. What's the degree here for x, for this factor? It's a 1. What's the degree here for this factor? 1. And the degree here is 2. I have 1, 1, and 2. That makes a total of what? 4. Makes a total of 4. So this is a degree of 4. You basically add up the multiplicities, and that's how you find the degree when it's already in its factor form. You can FOIL it and distribute and do all of that, but you're going to be wasting time to do that just to figure out that it's a 4. Okay? Now, to figure out your leading coefficients, okay, you really just look to see if it's positive or negative. Look at each one of these coefficients that are in front of the x. Every single one of them is what? Positive. So if you were to actually FOIL this out, it's going to be a positive number. So right now, show me with your arms, what does a even, degree, and a positive leading coefficient look like? It's good. Exactly. Okay? So basically, our ends are going to look like this. Okay? They're both going to be pointing up. So what's that end behavior? Positive infinity here. And then when it approaches negative infinity, it's going to be what? Positive infinity. Very good. Is everybody okay? Have I lost anybody yet?
Wait, do you write this next to the thing?
No, this is going in the notes. Second page of the notes. At the very bottom. Now we have to determine the zeros and state the multiplicity. I already wrote too big. Not out of space. Okay? So we need to, since it's already in factor form, we can go straight into applying zero product property. So I'm going to set every single factor equal to 0. You know, I had to do parentheses. I don't know what I was thinking when I wrote that. Okay. So here we go. Our first one is going to be 0, 0. Okay? What's going to be this one? Negative 3 over 2, 0, because you know we have to subtract 3, divide by 2. So it's going to be negative 3 over 2, 0. And what's the last one going to be? 1, 0, because we add 1 to the other side and we get 1, 0. So there are our zeros. What's the multiplicity of this first one? 1. It was a multiplicity of 1. So I'm going to put, okay? There's a multiplicity of 1 for this one because you go back and you look at the original factored form. What's the multiplicity of negative 3 over 2, 0? 1. And what's the multiplicity of 1, 0? 2.
Wait, why is it 2?
Because when we go back and look at the factored form, since it had a degree of 2, that lets us know that it has a multiplicity of 2. Which means that 0, 0 is going to what?
Touch.
Cross, because it's odd. At negative 3 over 2, 0 is going to cross, and at 1, 0 is going to touch. So, alright, so we got 0, 0, negative 3 over 2, 0, which is like negative 0.50, and then 1, 0. These are our points, these are our x-intercepts. Okay? It's going to cross at negative 3 over 2, 0. It's going to touch here, and then it's going to cross. Oh, just kidding. Sorry. Backwards. It's going to cross at 0, 0, and then it's going to touch at 1, 0. Keep that in mind when you're trying to graph this, okay? Now, at this point, can you kind of see what's going to happen here? It has this end behavior up here. It has to cross through. It has to cross through, and then it has to touch here. Did everybody catch that? If you didn't, then apply C. C says to do some additional points, okay? Do some additional points. Now, I don't suggest doing 0, negative 3 over 2, or 1, okay? Do some other ones. What's some other points that we could do? 2. 2 is a good one because it's after that point here. It's another good one. Negative 2. And even, whoa, even negative 1. Just so you can kind of have an idea, okay? And all you do is you plug those points into the function and figure out what they are, because those are going to be other points that are on this, okay? So here are a few additional points. At positive 2, you're at 14, so you're all the way up here somewhere. That kind of confirms the whole end behavior continuing to go up type thing, right? Then at negative 1, you're at negative 4, okay? I actually plotted that one. That was actually on my graph. And then at negative 2, you're back up here at positive 18, okay? Now, if you can't see it, hopefully you see it now, that this graph is coming from all the way up here from somewhere, crossing at negative 3 over 2, going through this point. Now, I don't know for sure if it's a max or a min. We'll deal with that later on in the unit. It's crossing here, and then it's going to touch at 1, 0 and continue to go up. Okay? Questions? Yes, yes.
What if, like, we didn't do C, like what we had to have?
Then you're good. Yeah. A lot of times I'll probably even ask you to do the extra points. If I do want you to do it, I'll probably give you points and I want you to find the whys that go with it.
That little curve, why would you just, like, how would you know how big to do?
Well, this one right here.
Yeah, like, that's what she said.
That right there is some point that's in between there. That's going to represent some type of max or min.
I'm
We're not.
saying, would you be able to go higher?
come back and ricochet off of one.
So it doesn't matter.
It doesn't matter. Especially for this, because since I didn't ask you to figure out where the maxes and mins were, I'm not going to be looking for that in the graph. I'm going to be looking to see if you got the end behavior right. I'm looking to see if you got the end behavior right. If you're actually crossing and touching the x-axis where you're supposed to be. That's really what I'm going to be looking for. Questions? It's all we put together. You're going to do one more, okay? This one is going to go right beside the pink form. Pink form, okay? All right. With your arms, what's it look like? Yes. It should look like this. So that means that I'm up on this end, but I'm down on this end. Down on this end. Okay? What was my end behavior? The limit as x approaches positive infinity is negative. And the limit as x approaches negative infinity is positive infinity. What were the zeros?
0, 0. 4, 0.
And you got that by factoring. You take out a negative x, because every single term has an x in common. And remember, last class I told you it'd be a lot easier on yourself if you take the negative out. Okay, so now we have a positive x squared, a negative 2x, and a negative 8. Just remember, you got to change your signs. Factor that. What were the two factors?
4 and 2.
And that's how you guys got that. What's the multiplicity of 0, 0?
1.
And the multiplicity of 4, 0? And negative 2, 0?
1.
Okay. On your test, I probably will ask you to write multiplicity like on a separate line, not side by side, because I might just be like, what are these random like lines that you have here? I wouldn't even think that you're doing that. Please don't do what I'm doing. I'm just running out of space. Okay. So I'm crossing here, and I'm crossing over here. And if I follow this kind of pattern, I should be here. Okay. Roughly. If you plugged in an extra point at -1, it was actually -5, so it actually did go down that far, but it went really high up over there.
How do you do the two multiplicity?
Me neither.
If when you factor this, say you actually had to factor it yourself, and you ended up with, what's the example I gave the other day? I'm trying to remember. Say you end up with something like this, and you had to factor this. It would have been x minus 2, which is the same thing as saying x minus 2 squared. So that would be the multiplicity of 2.
That's why in the group one, the school one is like 4 minus 7.
No, this would actually be on one, like, say you had to factor out an additional x, and this is what you were left with. So you actually have 0, 0 as one of your things, and then 2, 0, but it would be touching at 2, 0. It would actually come from I can say what this is.